Hey, how's it going on, guys? So in this video, we'll discuss about this problem, dungeon game. So in this question, we'll be given a two-dimensional array, something like this. Now my job is to move from this index, that is the top left corner, to this index, that is the bottom right corner. Correct. Now we have to find the minimum health required to move from this point to this point. Now in the array, there are going to be negative values and positive values. So whenever we are hitting a negative value, our health is going to get reduced by this value. So in case I'm hitting this thing, my health is going to get reduced by 3. And in case we are hitting a positive value, our health is going to get increased by that amount. So in case I'm hitting this cell, my health is going to get increased by 3. So we need to find the minimum health required to reach from this point to this point. A couple of things to note over here is the only way I can move is either to the right or to the down. It is given in the question. And one more thing, and at any instance, my health should not reduce to less than 1. So it should be greater than 1 in all the cases, that is greater than equals to 1. So let us consider one example first. So in this example, it is given that the minimum health required is 7. If we follow the path, right, down, down. So let me just show you guys this thing. So this is the same example. So what it's saying is we have to start from here. This is our starting point. And we have to reach over here. This is our finish. So it is saying that we have to move right, down, down. So right, down, down. Correct. So it's saying that in case the initial health is 7, this will satisfy. So let us see. So in case our health is 7, it will get reduced by 2. So over here we will be having health of 5. Over here the health will get reduced by 3 again. So over here we will be having a health of 2. Over here the value is 3. So the health is going to get incremented by 3. So it will be 5. And finally it will get incremented by 1 more. So it will be 6 over here. And lastly over here the health is going to get reduced by 5. So it will be 1. So you can see that in this path, the health is not reduced to less than 1 in any situation. So that's why this is the answer to this question. So now let us see how we can solve this problem. See, from any point, this is the starting point and this is the finish. We know this. Now from here, I can only move either to the right or to the bottom. So what I can do is I can write a recursion and I will try to find the answer to the problem from this index to this index and from this index to again this index. I'll just take the minimum of these two. So what I'm saying is from here I can either move to right or to the bottom. Now I'll write the recursion to find the minimum health required from this end to this end and from this end to this end. I'll just take the minimum of these two values and I'll just subtract the current health. So let's take an example. So let us suppose that the minimum health required from this cell is 5 to reach over here. And from this cell it is 7. We are just assuming these two things. Now what I'm saying is, what is the minimum health required from this cell? This is going to be equals to minimum of 5, 7 minus this value. That is minus 2. So minimum of 5, 7 is going to be 5. And when we are subtracting minus 2 out of it, it is going to be equals to 7. So what I'm saying is when you are, so from here the answer is going to be 7 because it will start here at health 7, it will get reduced to 2 and we will have 5 health over here which is satisfied. So that's why we are doing it. Why are we subtracting it? So let's consider the other case in case this value is positive. So let us suppose this value is plus 2. Let us just suppose this thing. So in that case we will be doing this again, that is minimum of 5, 7 minus plus 2. So this will be equals to 3. So what I'm saying is I'll start with 3 from here and I'll gain this 2 health from here and I'll reach over here with 5 health. So this is satisfied. So over here I can either gain health or I can lose health. That's why we are subtracting this thing. Correct. So in case I write the recursion for this, the recurrence relation will be something like, for in case the recursive method is f. So for I, j, what I will do is I'll find the minimum of f of I plus 1, j and f of I, j plus 1. So if you see this is I, j, then this will be I plus 1j and this will be ij plus 1. So I'll try to find the minimum of these two and we will simply subtract the current array value which is dungeon in the equation. So I'm just taking this as array. I'll just subtract this thing. So this will be the minimum health required from this thing. Now one more thing, it might be possible that this value is reduced to 0 or less than equals to 0. So which is not possible. So I'll just do what I'll just take this, I'll just take its maximum with 1, correct? So that this value remains greater than equals to 1. Okay. Now you might think that is there any case where this value gets reduced to like negative? It is possible. Let us suppose this is not plus 2, this is plus 20. In that case, if we do minimum of 5,7 minus plus 20, so this will be equals to minus 15. So if you see, basically I'm saying that if I am having a minus 15 health and I gain 20 health, I'll reach over here with 5 health. But the problem is at any instance in the path, the health should be greater than equals to 1, which is not satisfied. So in this case, I won't be taking this value, but I will be taking this value. Okay. So I guess that's it. One more thing. What is the base case? So the base case is also simple. So in case we are hitting this index, that is the last index. So what we can do is simply we can check this. So if this let us say this value is x. So in case this x is positive, in case it is positive, we will just take a question mark. In case this is positive, what we will do is we will simply take 1, we will simply return 1. And otherwise what we will do is we will take the absolute value of this x and we will add 1 to it. Why is this? Just suppose this now, the value over here is minus 5. So what is the minimum health required at this edge, at this point? It's 6, correct? Because it's going to get reduced by 5. So the minimum health will be 1. So that's why you are taking this thing. And what will happen if this is not minus 5, this is plus 5? In that case, we can say that the minimum health required at this point is 1 because it's going to get incremented only. It's not going to get decremented. So that's why it is 1 over here. So I guess that's it. So let me just write the code for this thing and then things will be more clear. Okay, so let me write the recursive method. So it's going to return an int. Let's name it mhr, minimum health required. So it will take this array, let's name it array only, and we will have 2 index I comma j. Okay, so I'm going to call this method from here with this array, that is dungeon with 0 comma 0, that is the top left corner. Now what I'm saying is at any instance I have only 2 choices. So I'll just say return. What I will do is, as already discussed, I'll take the minimum of the recursion, that is I'll call for arr I plus 1 j and mhr arr I j plus 1. We are calling for these two, and what we are going to do is we take the minimum of this and we simply say we will subtract this with arr ij. So this is what we are going to return. One more thing that I just discussed this, it might be possible that this value is less than 1. So what we will do is simply take math.max of 1 comma this value that we just did. Alright, now about the base case. In case I equal arr dot length and j equal arr dot length, this is arr 0 dot length, that is the bottom right corner. In that case, what we have to do is we will return, we will check in case arr ij, in case this is positive. In case this is positive, we are simply going to return 1, else we are going to return math dot absolute of this value plus 1. One more base case is there. In case we are out of the rows or columns, what I'm saying is, so when I'm over here, I'll try to call for this thing and this thing, but there is nothing on the right, correct? Similarly, if I'm over here, I'll try to call for this or this, so there is nothing at the bottom. So we have to handle these cases as well. So for these cases, we'll simply return integer.max value, so that when we are picking the minimum of the 2 recursions, we will pick the second recursion always. So let me just write that thing as well. So in case I equal so this is minus 1 and this is also minus 1 because we are considering the index, and in case I equal arr dot length or j equal arr 0 dot length, in that case we will simply return integer dot max value. So I guess that's it. Let me run this code once. So it's giving the correct result. Let me submit a solution. So it's giving a TLE. Let's try to analyze why it's giving a TLE. So over here I've just drawn the recursion tree. So if you see in the recursion tree, there are two values, that is MHR 1,1, which is repeating. So what we are doing is, this is again a problem of dynamic programming. So we are trying to find the problem which are repeated again and again, and that's adding to our complexity. So the thing is that if we have calculated the recursion for 1,1, there is no need to find the value for 1,1 again. We can simply store the value whenever we are writing it for the first time. So that's what we are going to do in this question. So we are going to have a DP array. Now the question is it going to be a single dimensional or double dimensional or two dimensional? See, this depends, and this depends upon the number of variables in the question. You can simply see that the number of variables over here are only 2, I, j. So we'll simply say we will take a two-dimensional array. Now what should be the size? See, the worst value for I is going to be what? This thing, AR.length. And what is the worst value of j? This is going to be this thing. So we have to hold these values as well. So we'll simply say this will be equals to this plus 1 and j, and this is going to be this plus 1, because we have to hold these values as well, correct? Now what we can do is, let me just initialize this DP array as well. For int I equals 0, I less than ARR dot length plus 1, I plus plus, we can say arrays dot fill DP of I with -1. So I'll be passing this DP array over here. So I'll be getting the DP array over here as well. So when you're calling the recursion, you have to pass the DP array as well. Now before checking anything, I'll just check in case DP of ij, if this is not -1, we are returning DP of ij. So initially we are initializing the DP array with -1. In case the value is not -1, we are going to return DP of ij. So when are we going to set the value for DP ij? So we are going to set over here in the recursion. See, we can set over here as well for these two things. But the thing is that these two things, if you see, these two conditions are O1 complexity. This is O1 complexity. This is again O1 complexity. So there is no point of adding DP of ij over here. There is no point of storing these two values as well. We can store it or we cannot. It doesn't matter. Correct. The point is that we are calling the recursion over here and over here. So we are storing the result over here. And before calling the recursion, we are just going to check whether the value is not -1. We will just return it. See. So let me just submit this code once. It's giving a compile time error. Okay, so this is dungeon, right? We have passed the dungeon array as ARR. So let me just submit this again. So it got accepted. So I guess that's it from this video. In case you have learned anything from the video, you can hit that like button, and in order to support my work, you may consider subscribing to my channel. Thank you all.